Let's talk about the Rubik's Cube. I bought one a few weeks ago just to have some fun, but I'm really interested in trying to solve it mathematically. We need some kind of notation to describe the movements. I prefer to use the minus sign for anti-clockwise rotation. Let's name each face of the cube as right, left, up, down, front, and back. Then define each rotation as a 90-degree clockwise rotation. So R is one 90-degree clockwise rotation of the right face of the cube. 2R, which equals R plus R, is a 90-degree clockwise rotation, which is equal to 180-degree clockwise rotation. Minus R is one 90-degree anticlockwise rotation. 4R equals 0. 4 rotations is equal to 0 since it is a 360-degree rotation and the cube doesn't change. R equals minus 3R. 1 clockwise rotation is equal to 3 anticlockwise rotations. With this notation, it's possible to add and subtract the rotations. The only problem is that the addition is usually not commutative. R plus U is not equal to U plus R, but the addition of parallel layers is commutative. The shortest route is usually to trace back the movements used to jumble the cube. Unfortunately, that may be very difficult unless you record all those movements. Most people then seem to use some algorithm that ignores the initial jumbled state of the cube and takes the cube to a much longer route. But exactly because the algorithm is independent of the initial state of the cube, it seems to be simpler to use. The cube is made of 3 kinds of pieces. The piece at the center of each face has only one color and never moves relative to the other centers. The pieces at the edge have 2 colors. The pieces at the corners have 3 colors. There is only one correct place for each piece, but a piece at the correct place may still be at the wrong orientation. The edge pieces have 2 possible orientations. The corner pieces have 3 possible orientations. It's not enough to move the piece to the correct place. It also needs to be in the correct orientation. There are 8 corners in the cube. For each corner, there are 3 possible orientations. So there are 3 times 8, or 24 possible combinations, but only one is the correct combination for any given corner. Each corner has 3 adjacent corners, 3 diagonal corners, and 1 opposite corner. 2 adjacent corners determine the intersection of 2 faces. There are 2 ways to move a corner piece to an adjacent corner. You can rotate either intersecting face to move the piece, but only one will produce the correct orientation. A diagonal corner is 2 corners away. An opposite corner is 3 corners away. So to move a piece to a diagonal corner, there are 2 times 2 or 4 ways, but only one will produce the correct orientation. To move a piece to the opposite corner, there are 2 times 2 times 2 or 8 ways. And these are all the shortest ways to move. It's possible to move longer ways. Even though there may be many ways to move a corner piece to another corner, there is only one way that produces the right orientation. There are 12 edge pieces in the cube. Each edge piece has 2 possible orientations, so there are 2 times 12 or 24 possible combinations, but only one is the correct combination for any given piece. By representing all operations as mathematical equations, it may be possible to completely solve a Rubik's Cube algebraically without using the cube. By manipulating the operations mathematically, it may also be possible to find the shortest way to solve the cube, one that uses the least amount of movements. How to represent the configuration of the cube? Each of the 6 faces has 9 pieces, each piece with a color, so the cube has 9 times 6 or 54 colors, so the cube can be completely described by 54 places occupied by 54 colors. If each color is in the right place, the cube is solved. But the centerpieces never change positions, so we can ignore them. So that leaves 54 minus 6, or 48 pieces occupied by 48 colors. A complete description of the solved cube with each color in its correct position could be: I am defining the position of each color as a circle around the face, so the rotation of a face becomes just a shifting of the numbers to the left or right. Visually, it is like this. What happens if I turn the right face clockwise 90 degrees? Rubik's Cube competitions are more about finger speed than finding better ways to solve the cube. Personally, I'm not really interested in knowing who has the fastest fingers. A much more interesting problem is how to find the most useful mathematical representation of the cube, one that not only can solve the cube, but also finds the best, shortest solution. It is possible to imagine a four-dimensional Rubik's Cube, or a Rubik's Tesseract. Such a cube is impossible to manufacture and can only be manipulated mathematically. Is it possible to have a two-dimensional Rubik's Cube, a Rubik's Square? I don't know, even though it seems to be simpler. Imagine a 3 by 3 square. How do you manipulate it? A cube has 6 faces, so 6 colors. A square has 4 sides, so 4 colors. What do you do with these colors? What is the color of the corners? Also, instead of a 3 to the power 3 cube, it is perfectly possible to imagine 100 to the power 3 cube or 10,000 to the power 3 cube. Such a cube could be too big to manufacture and manipulate by hand. But mathematically, such a cube would be no different than a normal cube and would be perfectly solvable. I am ignoring the middle layer. The rotation of the middle layers is exactly equal to the rotation of the adjacent layers in the opposite direction. I also ignore the pieces at the center of each face, since they don't move relative to one another. It is also possible to ignore anti-clockwise rotation, since they are equal to 3 clockwise rotations. I don't know if that simplifies or complicates the problem. One rotation of a face moves 20 colors, 8 colors on the face itself and 12 colors on the surrounding neighboring faces. I am using an Excel file to represent the cube, where I open the cube and can see all 6 faces at once. It is just a way to turn a 3-dimensional object into a 2-dimensional representation. I could write a VBA script to move all the colors automatically with every rotation. Right now I have to move all colors by hand, and it is easy to make mistakes.